Alright, so today we're going to be talking about adding and subtracting polynomials. So basically all we're doing today is just combining like terms. So we're going to be given some polynomials, which is basically just an expression that has, variables and numbers, so multiple numbers. And we're going to be asked to simplify each expression. So we're not solving for anything today, just simplifying. So the key here, and the thing that's going to be new to you guys this year compared to previous years, is we're going to have to deal more with the exponent part of simplifying. So one of the key parts of combining like terms is you got to understand what a like term is. And a like term is a number that has the same variable and the same exponent. If it has different exponents, they're not like terms, they cannot be combined. Now there's an order in which expressions should be written, and it's usually descending value with exponents. So for example, if I had 2 plus 4x plus 5x to the third plus x squared, the proper way this should be written is with the largest exponent first, then the next exponent, then the next, and then if there's a constant, which is just a number, that would be last. So the way this should be properly written would be 5x to the third plus x squared plus 4x plus 2. And that's going to help us today because one of the things we're going to have to do is we're going to have to state the leading coefficients and the degree of the polynomial. So basically what it's saying is it wants you to look at the leading number here, and it wants you to state the coefficient. So that's the number in front, coefficient. Okay? And then the degree, which is just the exponent. So the exponent of that leading number. It wants you to state both of those after you've simplified it. Okay? So let's go through this and let's see if we can do this. So we've got some polynomials here. The key thing we need to look at when we see this grouping is if it is subtracting. So this right here. If it's subtracting, we got to pay attention to the grouping. Because what that really is, it's like saying you're multiplying this second group by a -1. So when you distribute that, it doesn't really change the numbers at all, it just changes the signs. So that 4b to the third is going to become -4b to the third, and that -6 is going to become +6. So let me rewrite it, and when I rewrite it, I'm going to take away the grouping, because after that, the grouping doesn't matter. Okay, so 1 minus 2b to the third, because if you're just adding at that point once you've distributed. So minus 4b to the third, or plus 6. Okay? So the common mistake there is a lot of students will drop the grouping and just put the minus to the 4b to the third. But again, it has to go to both terms because you're subtracting that entire group. Okay? Now it's just a question of combining like terms. So if I look, I've got -2b to the third and -4b to the third. They have the same variable. They have the same exponent. They're like terms. I can combine them. And when I combine them, -2 plus -4 is a -6. So -6b to the third. You just add the coefficients. The exponent will stay the same. Does not change at all. The only thing that is happening is you are combining the coefficients. Okay? The only way to change exponents is to multiply, which we will get to later. Okay? And then the constants 1 and 6 would combine and become 7. So plus 7. So there is my simplified expression, -6b to the third plus 7. Now it wants me to state the leading coefficient and the degree. So the leading coefficient is the number in front of my first variable here, which is -6. Okay, and the degree is the exponent, so 3. And that would be my answer. Okay. Let's try one that's adding. So if we look over here at our second problem, we're adding here. Now, it's grouped, but does it really matter? Because there's nothing to distribute. That'd be like multiplying a positive one, which would everything would stay the same, right? So the grouping doesn't really matter when it's just adding. You can just get rid of the grouping and just start combining right away if you're adding, because there's nothing being distributed. Okay? So we're going to look for like terms. So, well, let's rewrite it without the grouping, just so you guys can see. Negative 6p plus 2p to the third plus 6p to the third minus 2p. Okay? So no grouping. So again, like terms are numbers that have the same variable and the same exponent. So negative 6p and 2p to the third do not have the same exponent. They have the same variable, but not the same exponent. Because they don't have the same exponent, you can't combine them. Okay? But 2p to the third and 6p to the third do have the same exponent, so I can combine those. And I'm going to get 8p to the third. And then negative 6p and negative 2b have the same exponent, so I can combine those, and it would be negative 8p. Okay? So there is my solved or simplified expression. Now wants the leading coefficient, so that's the number in front of my first term that has the highest exponent there, so it's positive 8. So leading coefficient is 8, and then the degree would be 3. Okay? So that is your answer for that problem. Let's do one more. Let's do one of our more complex ones down here. Let's look at number 10 here. So I've got a subtraction grouping here. So again, you have to distribute that negative to each term in that group. So let's rewrite things with the negative distributed. So I have negative 2p plus 2 minus 2p squared in my first group. And then the second group is going to become minus 5, minus 6p, and minus p squared. So they all turned negative. Now, next step is to look for my like terms. So I'm going to do the shape approach here. So let's put, so just the p by itself we'll put in a square. Constants we'll put in a circle. And we'll do a triangle, kind of, over the exponent ones. Okay. So let's start with the highest exponent because that has to go in front, right? So I have negative 2p squared and negative p squared. What coefficient is in front of just p? It'd be a 1, right? So it'd be like negative 2 plus negative 1, which would combine to become negative 3p squared. Okay? Then I've got negative 2p and negative 6p, which combine to become negative 8p. And then I've got positive 2 and negative 5. Combine those, I would get negative 3. So there is my simplified expression. Now, leading coefficient. Again, you look for the term in the front with the highest exponent. So the coefficient in front of that one is negative 3. Negative 3. A lot of students will make a mistake of looking for the highest coefficient, which negative 8 is technically less than negative 3, but they look for the biggest number. That's not what you're looking for. You're looking for just that first term. Okay, and then you're doing the coefficient of that. And then the degree of that term is 2. And that is your answer for that one. Not too tough, right? That is adding and subtracting polynomials.